Hello, it's Duncan. We left the last episode with the realization that we can't automatically delegate from an interface of suspend functions to an interface of non-suspend functions. That seems like quite an arcane problem, but the solution is generally very useful. It turns out we can implement interfaces at runtime, running dynamic code to respond to method calls. This can save us from writing lots of boilerplate code, and is used in dependency injection, object relational mapping, and mocking. Unfortunately, this technique is only available on the JVM, so if you're a Kotlin purist, you may wish to look away now. For the rest of us, let's have fun with dynamic proxies. Is that good? It certainly is. This is where we ended up at the end of the last episode. We'd extracted this customer's repository type and an implementation of it in terms of mutable list. Now, this in-memory customers is very much not thread safe, which is something we might look at later. But we have another problem, which is that we want a coroutines version of this co-customers here, that is composed of suspend functions so that we don't have to block a thread if we're going to talk to an actual database. Now, unfortunately, we can't merge these two interfaces because the way that we call a suspend function and a non-suspend function is very different. The compiler actually has to build a state machine around the call of a suspend function. That, I think, is just the truth. But another truth that's more irritating is that we can't implement this co-customers in terms of in-memory customers. Well, I mean, we can, but we have to do it by hand. We either have to build a new version of in-memory customers, or I suppose we could say that class co-in-memory customers is a co-customers, yes, and in-memory customers, we'll call it delegate. So it's going to delegate to that, and then if we ask it to implement all of these, then each one of these things is going to have to say return delegate dot list and so on and so on. Now, obviously, an actual implementation of customers talking to a database will be different than a co-customers talking to a database, because this one will be able to use blocking APIs and this one will use suspend APIs. But for our in-memory case, it's a shame that we can't just delegate one to the other. That delegation is the challenge that I posed at the end of the last episode, and I think that I have got a way to do it. But we'll take time to get there. So first of all, let's just delete this. And before we go on, we're going to have a look at our throughput tests and imagine how to make these work if we didn't already have in-memory customers. These tests only list the customers and only expect an empty list back. So of all the customers interface, we're only calling one method. So what we could do would be to say, not in-memory customers here, but I just want an object that implements customers. And then ask IntelliJ to fill those in for me. And it will helpfully put in to-dos for everything. But we could now say, well, actually this list here, let's just return an empty list. And if we run that, then everything is good, because we're returning an empty list for the only one method of this customer that's actually called. Let's stop that. And I suppose you can think of this as a very specific mock object built without a framework. Still a bit of a pain though, because we've got these methods here, and if we add anything to customers as an interface, then we'll have to go and change our tests and so on. But there is a way that we can do better, at least on the JVM. So let's get rid of this, and we'll go to proxy, Java lang reflect proxy. Just going to have a look at that, see how long it's been around. And the answer is since Java 1.3. So that's pretty much the beginning of time. And what proxy has is a static method called new proxy instance. And what new proxy instance will do is build an implementation of an interface at runtime. Now, in order to do so, it needs a class loader, an array of classes, and an invocation handler. So let's see how we can get there. The class loader, we can use pretty much anything. I think we'll use the one from this test for now. So that would be this Java class loader. The next parameter is the interfaces we want to implement. And in our case, we know that's customers, and we need to provide it as an array. So we can say interfaces is not that, but array of customers class Java. And this .java is because class here returns a Kotlin reflection object, not a Java reflection object, but we can convert that. And then finally, we need an invocation handler. And you can see that's been completed for us. Let's have a look at what an invocation handler is. It's an interface that has a single method on it, which is invoke, that takes the proxy that the method is being invoked on, the method itself, and whatever arguments. and we return an object that we want to be the result of calling this method. Does that make sense? Well, let's have a look. Let's say we just return banana in here, which is allowable because this invocation handler invoke just returns object. And we're nearly there, but new proxy instance returns an object. We need to cast that to the thing we know we want, which is as customers. And some issue where it's not compiling here, none can be provided with the argument supplied. Well, it turns out the names of those parameters were completely wrong. So let's just get rid of them altogether. Now, if we run that, it fails, and it fails because we get an internal server error. Why is that? Well, in the case of Ktor, it seems to be buried. Let's have a look at HTTP for K. Now, again, we've lost it, but I can tell you the issue here is that we are returning a string rather than a list of customers, which is what the one method that we are calling expects. So I think if we change this to empty list of customer and run, then we start passing our tests. Brilliant. So maybe a better, more general solution to this problem would be to say that if the method we're being called with, we can ask for its name, is the one we think we want, which is this list, then we want to return an empty list of customer. Else, well, I think of this here, which we could say to do, fix all that to make it compile, and this would be no implementation for method $method. Reformat that, and now if we were to just try, for example, in here before we go on, saying customers dot find by ID thread and run that test, then we see we'd get our not implemented error, no implementation for method public abstract customer find by ID. So for an interface like customers, I'll put it over here with quite a few methods. This is almost as short as the object implementing with a lot of to-dos, but has the advantage that we could add methods into customers and it would continue to work. It's a bit of a shame, though, that we have to put this code in here. Can we do better? And the answer is we can, because Kotlin already has a way of delegating interfaces. So what I'm going to do is I'm going to say, let's just call this our proxy, and now we'll set up another private val customers, and this is going to be an object that implements customers by our proxy. That would work, it turns out, if we'd put a body on there. And weren't doing that. Okay, good. But now this object here will only delegate to this proxy for things that it doesn't define itself. So in fact, in here we can say override fun list to return our empty list. And that means we can take out this body here except for the to-do. So anything we explicitly define as an override inside this body will be called here, but everything else will be passed out to this new proxy instance, which will just say, I can't find that. So we're still good because we're only calling list and we have an implementation of list. And now we can do the usual thing, which is to take this here and generalize all the things. So let's put it out into a thing and we'll call it fake. Now we don't want this to be tied to customers.class.java. So let's pull that for now at least as a parameter. Instead of using the class loader from the test, we might as well use the class loader from this class. So we'll use class, which is a Java class already, .class loader. And now our invocation handler is telling us we can remove the constructor, the SAM constructor, and then we can pull that out of the parentheses. And we can make that an underscore. Still good. Still good. And now we can take this out of this test. I'm going to put it up above for the moment. And now we don't really want this to be tied to customers. So what we can do is we can make this an inline fun of a rarefied type. And now this is not a parameter, but we can use the T in here. So we can say T class.java.classloader. Here we can say T class.java, and here we can say as T. And then to call it, we can just use the type in here. So we say fake customers. Is that good? It certainly is. And now we can do without this proxy altogether, so we can inline that. So we have our customers is an object which implements customers by a fake customers, but overrides the one method we're interested in, returning an empty list. So fake is pretty cool and normally ends up in a Kotlin codebase if I've been there for long enough. So let's move it out of here into its own place. I think we'll say that can go in main, and we'll say util, and quite sure why we're not allowed to say that. Do it to create one, choose destination package. Oh, I don't know. I suppose we're telling it to a package. Let's say we want it in com example util / proxying.kt and refactor that. No. Come on, IntelliJ, don't embarrass me. What's going on there? Because there's no, I don't know. You know what? Put it in fake.kt in example, because that's all you are going to allow me to do. We'll add that to Git, and then we'll go and find it, and we will say, let's make this com example util. We will move it to there, and we will rename this file to be proxying. Marvelous. How does that break? Ha 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 ha. Oh dear, oh dear. Let's try rebuilding the project. And now that's broken, but that's all right. Now maybe we'll find it by import. Not the most edifying refactor, that. But we're back in business. Good. There's another hole that Java proxies have dug me out of, and that's if I want to pretend that something I don't control has an interface that I do control. And what do I mean by that? Well, let's say there was a version of this in-memory customers that was somebody else's code, and they haven't implemented our customer's interface. So I'm going to just fake that by putting it in here and say, we'll call it third-party customers. But that doesn't implement customers. Now, that's perfectly fine. It just can't override customers. That's all good. But now let's say we want to use this where we have a customers. So instead of customers here, we'd want to say, I've got my third-party customers, which is fine, but third-party customers doesn't implement our customers object. Now we could say as customers, but the fact is that it isn't a customers, and as the compiler is telling us here, this cast can never succeed. Note that it has the same interface here, it just doesn't say that it implements customers. So this can't succeed, but the structure is the same. What we actually want is structural typing, and we can do that with proxies as well. So let's just pretend that we have a method. I don't know, let's call it structurally typed as, and let's make that a type parameter. Now this would be easy to get wrong, so I think I'm going to start writing some tests. Let's generate our structurally typed as. So we'll create an extension function on anything for now, and then I'm going to move this into our proxying like that. And does this now build? No, but it will if I import. Okay. And I think I might call this structural typing tests. Okay. One of the things I've used this for in real life is to narrow a big interface into something smaller so that we know that we're only calling a small number of methods in our code. So the sort of thing I'm thinking of is if we had, for example, an interface of my collection. Now, if this is to implement collection, then collection has size, is empty, contains, iterator, contains all. But maybe I wanted a version that only returned an iterator and had size. So what I'd want in here is not the whole of collection, but we'd have val size is an int and fun iterator, and we'll pull the definition of that is an iterator of t, well, e. So my collection, for example, would be over E, and this would be E. So the sort of thing we might want to do is take an existing Kotlin collection and have a view of it as just my collection. So what would that look like? We would want to take something that's wrapped, say a list of banana and kumquat, and then my wrapper would be wrapped dot structurally typed as my collection. Now this is not compiling because third-party customers here. We need two types really. We'll say we've got a T1 and a T2. So this would be T1 structurally typed as T2, and that would allow this to compile. No, because you'd have to specify both. So in fact, I think we'll say this is any, and we'll just stick with one T. Are we good? We would be if we said we want this my collection of string. Okay then, let's just check that these tests actually run, which they do. And what do we have? An implementation is not permitted because we have a to do in here. Right. Okay, what's the behavior we want to see? Well, we'd like to be able to say assert equals 2 is the thing we get if we ask for wrapper size. And also assert equals, what do we want? We want that the wrapped, effectively, that list would be what we got if we took the wrapper, called iterator on it, and ask for the list of that to list. That doesn't appear to be a thing we can do. That sort of surprises me, but I suppose we can bodge it by saying as sequence to list. Some issue. I can't spell assert. Okay, that will continue to fail. Now then, let's use this as our pattern for how to implement a proxy. So we'll take the inline fun reified t as always being useful, and the new proxy instance like that. Now if we run our test, then we will fail with this to do. But now instead of this to do, what we can do is find a method on this receiver here that matches the method that's just been called, which is to say, find a method on this wrapped that matches the method on the wrapper. So what would that look like? Well, we will go to this, that's this receiver here, and we'll get its Java class, and at its simplest, we can call get method given the same name as the method that's just been called by us. So we can say that is method with method.name. And we also need to pass the parameter types, and our method has parameter types as well. So there's a chance that this is val matching method. And now we can say matching method invoke, and we want to invoke it on the wrapped thing, which is this any, so that's this. And we want to give it the arguments that we were given. It's not that, it is this arguments here. So let's put that in there. And I think as this is an array and this takes var args, we'll need to splat the array. Let's see how that does. Okay, so that's a bit irritating. What's happened is we've called this without any arguments, so that's been null, not an empty array. So let's just get ourselves working, I think, by passing no var args. No, still no good. Let's just see what matching method we got out. So we'll say println matching method, run. Oh, that's very strange. It passes. If I take that out, well, I don't know quite what happened before, but you can see that now, at least for two methods that take no parameters, we've called size on array list through size on my collection. Now that we know that the number of parameters is an issue, maybe we should change this from iterator to something else on list. See what we can call. We could say wrapped get at an index. That would be a good one. So we'll change this to get index, which is int, This is going to return an E. And now I think we should be able to say that kumquat is wrapper get 1. We run that. We don't expect it to work because we don't have the right number of arguments here. But now we think that we might say if args equals null, invoke without any, else matching method invoke with the arguments. Have a go. Splendid. Okay, I've just laid that out a bit better, and I think we might also say here that we could say here this is args and Elvis empty array. If so, we get rid of that and that, and one more there, and still good. So to make structural typing work, all we've had to do is build a proxy that finds a method with the same name and parameter types as the call we've just made, and then invoke it. I say all we have to do because if you are eagle-eyed, you may have noticed a little sleight of hand there. And that's that at some point I added this array list here. Now, why is that? Well, the answer is that if we do this and go straight to list of and run that, this fails. We fail with an undeclared throwable exception, and that's caused by an illegal access exception, which happens when we try and call this invoke. Now, I think we can solve that problem, but it'll take quite a time, and unless you're already an expert in Java reflection, I suspect this has been pretty heavy going. So let's leave that until next week. If you'd like to see that episode, then please do subscribe to the channel. If you press the notification bell, YouTube will tell you as soon as I've published. And if you could like this video as well, I'd really appreciate it, as it helps other people find the channel. And finally, if you haven't already, please consider buying the book that I wrote with that price, called Java to Kotlin, a Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.